Are you working in an agile environment like Scrum and you have a product owner from the business side, and whenever you want to implement non-functional requirements to improve the quality of your system, you have a hard time to argue against the product owner who has clear business requirements in your structured and prioritized backlog. This might be caused by, the non-functional requirements we typically get are in huge production readiness checklists or in huge security requirements lists to be implemented. It's like always a flat, huge list with all requirements on a must-do level, and this totally clashes with the agile working, where you have a prioritization, sprints, and you go always top down following the priorities. That's why I had the idea to copy the concept of the DevOps Health Radar into the world of non-functional requirements in the area of IT stability. This would work also for security, but I did it for IT stability because that's currently a big topic in my area. So I introduced the IT Stability Health Radar. And the idea is to check where your system is right now and see what are the next best improvements for your system to improve in the field of IT stability. My name is Elmar Brauch. I'm software developer and architect in Deutsche Telekom, and this is my channel Agile Coding. And if you are new to my channel, please hit the subscribe button, and if you enjoy the content, please give me a thumb up. So let's dig deeper now into the topic of IT Stability Health Radar. You see here an image of a health radar painted by myself. It has 4 different categories. We have high availability. That is about having your servers in a cluster, running redundant. If one server is down, the other server takes over and your system is available because it's always high available for your users. Yeah? If in the next category we have performance, this is about your system being able to deal with peak loads. For example, if you bought in the past tickets for big sports events or concerts, you might come with all users together and customers at the same time, and some systems just crash because of those load peaks. And performance non-functional requirements are really about caring about this and making sure that this doesn't happen. We have the category operations. Operations is about doing proper production deployments and having monitoring and alerting in place. If you are interested in details about proper deployments, which is a very important topic, have a look at the video here, which I link, because there you will see how I do it, and you can do it also in a safe and structured way. Our last category is resilient code. That is really for the developers to take care of those non-functional requirements while you are building your system, and therefore make sure that you can deal with exceptional cases. The resilient code is also the topic where I want to dive deeper, and therefore I will switch now to my blog article. I will link it in the description. Here you see in general the idea of the IT Stability Health Radar. I will explain why we have those 5 levels. Level 1 is really the foundation of a stable system, the must do for an MVP which goes to production. And level 5 is really the advanced stuff. If you have a mission critical system for your company, you should make it as stable as possible and therefore implement all the 5 levels. So categories. Here you can read the details about the requirements in all the different categories. I want to dive deeper in the category of resilient code, and let's start with level 1 requirement, error handling. Your application must catch exceptions and errors in a proper way and handle them, yeah, also in a proper way. Handling in a proper way could be logging it. In case you're calling an API, you could retry if you have an exception, or you convert the error into an own error message of your system. Yeah, all those things are possible. It really depends on the error type, whether it's a business error or a technical error, and it depends on the context where you are right now with your application. Reconnect is another level 1 requirement. Let's assume you are connected to another API which is down because they are doing a deployment or they have issues. Then the worst thing what could happen is that your application also crashes because your neighbor system is not available, and then 2 systems are down. Reconnect means you don't crash, you connect again, you do a reconnect as soon as the other system is up and running again. For APIs, that might be typically not the case that they crash your own system down, but if the database is gone which you are using, then this might happen. So therefore, take care about the reconnect capability. The last level 1 requirement, like level 1 requirements are always same priority, yeah, is test. Your application must be tested. You cannot think of a productive system which is considered to be stable and on the other hand not tested. Because then your users will test, and every bug they will find, they will consider it as some kind of instability and they will not like your system or will not use it. So tests are really an important level 1 functionality. But that doesn't mean that you have to do right from the scratch automatic regression tests. That's of course recommended to do test-driven development and to automate all your tests. But there is still a difference. Yeah, if you are just building a prototype, yeah, testing without automating it might be okay. I still don't recommend it, but you could do it this way. However, on level 2, which is also a super important level, we have directly the automation of regression tests and always execute them to make sure that your system doesn't get issues from one release to another release. Also, your end-to-end tests should be automated. End-to-end tests, automated end-to-end tests should focus first on the critical use case of your application, and as soon as the tests in this area are stable, yeah, you might decide to add more end-to-end tests. But having too much end-to-end tests, which often fail, yeah, is really a bad practice, because then you start not trusting them at all and ignore the errors which they show up. If you are interested in more details about testing, have a look at the video I will link here, and then you will see how I do the testing and handle the different levels. Yeah, then level 3 is empty in the category of resilient code, as level 5 is empty. Why are there empty categories? It's about comparing. Yeah, if you compare it with another category, like here the operations category, there we have level 3 requirements, and the main message is that those non-functional level 3 requirements are more important than the level 4 requirements in the category resilient code. On level 4 we have the retry non-functional requirement. We have another API, let's assume it crashes, and you call it when it's crashed, it fails, some time later it's there again, you retry and then it works. But let's assume the following thing happens. The other system crashes due to load, and you are constantly retrying, and that will block this other system from coming up again and working. So retry is not as simple as it sounds in the first view. Yeah, you must make sure to not flood other systems with your retry, and therefore you should have a proper back-off strategy, which means let's assume it crashed and you try, it fails, then you wait for 3 seconds before you try again. If it still fails, you wait 5 or 10 seconds, then you try again, wait again for a longer time, and then it works again. Yeah. So that means you implement a retry in combination with a proper back-off setting, and then it's fine. But just implementing retry, it's not a no-brainer. Keep that in mind. And then we have the stable I/O design as level 4 non-functional requirements. What does this mean? If your application has access to files or other data streams, you must handle them in a proper way, which means, for example, in Java, you close the access when you are done. If the file gets too big, you have a job which cleans it up so that the hard disk is not running full and that's not blocking your application. Yeah, so that is stable I/O design. And level 5 in the category resilient code is empty. I will not go into details about the other categories. I will show you now an example of my application. Here you see my system, and I changed the IT stability health radar to some kind of Excel table. We have the levels 1, 2, 3, and here we have 4. 5 is not shown on this slide. We have the different categories and all the requirements just noted down with the headline. And then we have those smileys which tell you, let's have a look in the resilient code category, reconnect, we have a green smiley, that means in my system it's implemented, error handling implemented, tests, automation of tests, retry is even implemented, but stable I/O design, we didn't implement it, because we don't have file access and so on, but that's also a way how to deal with it, that some requirements are not applicable for your application. But let's have a look in different categories like performance. Here we see the throttling for incoming requests. That's something what we didn't implement, even if it's on level 2. I did this IT stability health radar with a group of IT experts, and there we decided together on where the requirements should be, on which level, and why they are prioritized like this. And to be honest, I missed this, and didn't do that. Performance tests are done, caching is done, resource limits are done, and here in operations we have also things done beside the canary deployment and the alerting for timeouts and latency. So what are the next things to do for me and my system? After filling this out, pretty clear, we go level by level, and that means we should care about the throttling for incoming requests to protect the system for being overflowed by too many requests. That is something I have to do. And then in order to have a better deployment in the future, we should go for a canary deployment. If you are interested in details about this, have a look into the blog article which I shared in the description. And then what's your next step? You should also check where your system is right now with the help of the IT stability health radar, and then you will see the things to be done next, as in my case, this one and that one. With this, you go to your product owner and make sure that she or he gives it the proper priority in your team's backlog.